Okay, in this video, I want to go over how to solve for quadratic equations or find a solution of quadratic equations by using a quadratic formula given right here. Now, in addition to using a quadratic formula, you have to recall the discriminant, the facts that I is square root of -1 and I squared is equal to -1, and the standard form quadratic equation with the leading coefficient lowercase a multiply x squared plus the coefficient b times x and plus the constant c equals 0. Now, the discriminant is a shortcut for you to determine whether you're going to have no real solutions, aka two imaginary solutions, either one real solution or two real solutions. You're going to have two imaginary solutions if the radicand b squared minus 4ac, which is also known as a discriminant, is less than 0. Now, if the discriminant is equal to 0, that's one real solution. And of course, if it's greater than 0, then you're going to have two real number solutions. All right? So let's get started. These are the three examples that we are going to go over. So let's start with example 1. So example 1, we have 10x squared plus 3x minus 2 equals 0. Now, if we compare it to the standard form quadratic equation, notice that we have ax squared plus bx plus c equals 0. But over here, we got positive 10x squared plus 3x, but minus 2 equals 0. So how do we make it easier to determine the coefficients a, b, and c before we can even apply the quadratic formula? Well, simply, all we have to do is that we rewrite the minus sign into its plus form. So minus 2 is the same as plus -2. Okay, so from here, guess what? Our lowercase a is 10. Our lowercase b is 3. And our constant c, our constant c is -2. So that's our a, b, and c. Now, I can go ahead and plug in all of these into the quadratic formula first, but what I like to do is that I like to handle the discriminant on the side first, because I feel like that's going to make it easier for me when I apply the quadratic formula and show the work later, but hey, it's up to you guys whether you guys want to just fit everything in like your teacher has always taught you to do, but I like to do the discriminant on the side first. So with the discriminant, b squared minus 4 times a times c, well, that is the same as saying, oops, I don't know where you can see that. b squared minus 4 times a times c, that is the same as saying 3 squared minus 4 times a, which is positive 10, times c, which is -2. Well, what is this going to be equal to? We know 3 squared is 9. -4 times -2, that's positive 8. Positive 8 times positive 10, that is going to be plus 80. So, hey, this is actually going to be equal to 89, and this is greater than 0. So that means you're going to have two real solutions. In example number 1. So let's apply the quadratic formula. So the quadratic formula is x equal -b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. But hey, we know b squared minus 4ac is 89, so we're just gonna replace the radicand with positive 89. So negative b is actually negative of positive 3, which is -3, plus or minus square root of 89, all divided by 2 times a. But we know 2 times a is 2 times 10, so 2 times 10 is 20. Now we have plus or minus, okay? So that means we're going to have two different x values, one with a plus and one with a minus. So let's see. I'm going to write it like this. I'm going to have x equal negative 3 over 20 plus square root of 89 over 20. And then I'm going to have an x value, x equal negative 3 over 20 minus square root of 89 over 20. And yeah, I don't think we can simplify any further because 89, I think 89 is a prime number. So yeah, I don't think we can simplify any further than that. But yeah, this is how we do example 1. So two real number solutions are x equal negative 3 over 20 plus this, and x equal negative 3 over 20 minus the same thing.